Hi, this is Reddy. Welcome back to Reddy Controls. In this video, we're going to talk about how to connect sinking input, sourcing inputs to CompactLogix L2 PLC. Before we begin the video, if you like my content, please share, subscribe, and leave a comment. Now we'll go ahead and wire this PLC. The first thing we need to supply to this PLC is 24 VDC and common and a field ground. I already have a 24 VDC power supply which is hooked up to this terminal block over there. As you can see, that's the terminal block. The white is where I'm getting 24 hot, and the shield is the common one. And this is a terminal block. Terminal blocks are connected vertically, and we have these jumpers which connect them horizontally. To check them, let's use a multimeter and verify continuity on it. So we have a multimeter right now. I have a clamp-on multimeter. It's a true RMS. Make sure you have a true RMS, and it's a category 3 rated. I have another multimeter which has more options on it, but for now, just a regular multimeter. I'm using a Milwaukee, and it's in off status, and it's a Cat 3 rated for industrial, and it's up to 600 volts. Okay, so we'll go ahead and use the prongs, the testing leads, and we connect the red one. Connect the red one to the red side here, the voltage or impedance, and we take the black one, connect to the common. All right, and it's an off, and these are the ends. So to do continuity check, we change the mode to a impedance mode or a beep mode, which beeps when it sees a closed condition. You can see I have both the leads touching each other, and we have a beep saying like there is a continuity in it. So to check the terminal, this is the terminal block, and as we talked about before, terminal blocks are shorted or connected together across vertically, but with this bridge, it's also connected horizontal. So all we are trying to do is take the 24 DC here and make this a 24 DC terminal. So anywhere we plug a wire into this, we get 24 DC hot. Okay, so for example, these two are connected together. It's beeping, saying like there is a continuity. But since there is a divider here, if I put this black lead into here, it should not beep, saying like these two terminal blocks are isolated, and that isolation is happening on due to this plate. That's the isolation plate. So that's all it is. So we have 24 DC coming in, and all of this will be 24 DC hot. This is 24 DC hot. So all these terminal block, wherever we put the meter to the common, we get 24 hot. This is a common, so this is where you go ahead and get your common. And this is your ground in green in color. That's your field ground. And that's it. That's all about the terminal block here. I have plugged in the power supply. Now we'll take the meter and verify voltage. To do that, one thing with this push type, we had to push it to release it. So I had to push that orange one to the bottom one, push it to release like this one, right? So you can see it's right here. It's a push to release. So I had to push that and release it out. So it got like a push to release. You can plug in, but to plug it out, you need to use a screwdriver to push this orange thing. That will release the cage clamp inside, and you could get the wire out. Okay. So now to measure voltage, we need to change the meter to voltage mode with the DC. solid line and a dotted line is for DC. A tilde sign is for alternating current. This is for direct current. So now we have it in DC mode. Now let's see how much voltage we have. So I plug in on my 24 hot. This is the white wire, and then we go to the common. So you can see we have 23.9 VDC. So we have a good power supply. Now we'll go ahead and wire this 24 hot and common to the PLC. So to do that, we already have the 24 VDC terminal here in the common. So we need to run a blue wire from the 24 DC common to here, and one more wire from, blue wire from 24 VDC positive to 24 VDC positive here, and a common to common here, and a ground to ground here. Okay, I'll go ahead and turn the power off and then wire everything up and turn the power back on. Put it in the hot and the common. I should not read anything. It's almost zero. Okay, so now I know it's safe to go ahead and do it. We'll turn the thing off. So now we have already have two wires here. One is the common blue. I need to get one for 24 DC. If you look at the manual on how to wire this one, there is a spec for how much length of a ferrule do we need. So it says this is where it says connect the 24 positive to an external power supply, strip 8 mm insulation from end of the wire that you can connect to the 24 DC terminal on the controller. So we have already a stripped wire with ferrule on it. So we'll go ahead and plug that. It's a push. So we just go ahead and push it, and it made a connection. So now the other end of that goes to the 24 positive here. So we go ahead and I'll open it and do a small pull test, make sure it's tight. And then we already have the common, which is connected to the common there. We'll plug it back to the common on the PLC. Go ahead and loosen that one up and that's the common, and we'll go ahead and do the field ground to field ground using the green wire, which is plugged there. We'll go ahead and plug it in. Land it here. Oops, all right, so that's how we wired it. Now we'll go ahead and turn the power on. Now you could see the light, the OK light became solid and booted up OK. So I don't know if you can see the lights. See the so everything came up solid green. That means we have no problem with proceeding to the next step, which is talking about how to wire inputs and outputs to this PLC. So this is where the topic comes in about syncing and sourcing. There are a lot of videos on YouTube who explain it. I'll try to do my best to explain. Series of controllers, if you look at, we are using 1769-L24ER-QB1B. It says it can be wired as syncing or sourcing 24 DC digital inputs. Okay, these are embedded ones. So what does syncing and sourcing means? Okay, so we'll go back to the paper. Say we have this is our power supply. This is our 24 DC power supply, 24 VDC power supply. positive and negative. Okay, let's put that in a box. So we might have a field device which could be a simple push button. When you push it, you have both normally open, normally closed contact. When you push it, normally open contacts close and normally closed contacts open. That's what the terminology normally open means. That means on the shelf, when it's not actuated, it is going to be open. That's what these contacts 3 and 4 are normally open. Contacts 1 and 2 is normally closed. Okay, say we want to use normally open push button, so that's what this is. So this would be normally open, would be terminal 3 on this one, and then we take 4 and we just call it a push button normally open. Okay, we have a normally open push button. All right, now coming back into the PLC, just draw a box for PLC and it will go into an input. Say we call it input 0. Okay, so if you look at the flow of current, it leaves the positive terminal, comes back to negative. So let's put an arrow like this. That's the flow of the current. Since this normally open push button is source of the current, this is considered as sourcing device. That means it's a source or it's directly connected to positive. That's sourcing. Since this device is sinking the current, that means it's being connected to negative. This is called as sinking input device. So whenever we have a sourcing field device, we'll always have a sinking input device. The other way to look at it is sourcing gives a path to the positive common or positive terminal, a direct path to the positive terminal, and a sinking gives a path to the negative. Okay. So this is working as a sourcing, and that's the sinking. Sourcing provides a path to supply source positive, sinking provides path to supply common. Okay. So if you look at our manual from the manufacturer, he's showing us this terminology. That means you could wire your field devices as a sinking or a sourcing mode. Right now we showed a sourcing mode, but you could also connect this L2 processor inputs in sinking mode. Okay. So let's see how that looks. So if we look at this one, sourcing, we could see our push button is connected to, so your input card can be wired as a can be wired as a sinking input card or a sourcing input card. So we will draw the sourcing. Same thing, we have a '24 DC power supply, positive and negative. And so now to make PLC as a sourcing, we will put the PLC here and then our push button here. So this is our push button. The push button is connected to the negative, which is sinking. The current flows this way. The PLC is providing a path to the supply source. So this is sourcing, and the push button is connected to a path to the common. That means it's sinking to the common. Okay. Those are the two combinations for a field device and a PLC input. So this is the PLC input. Okay. So using this, let's go ahead and wire both of these combinations and show how to wire it. Okay. We will use this one as a reference for the first one, where we are doing a PLC is in a syncing mode. So we'll go ahead and wire it in that one. Okay. Now is that you completed watching this video. If you like more content like this, please leave a comment. Your comments will drive my next video.